Okay, now we're going to define the trapezoidal approximation graphs. And we use, for first example, we have y versus x. And we want to do a trapezoidal approximation of y versus x from x equals a to x equals b using 4 trapezoids on equal intervals. Now what could that mean? Well, here we have x equals a and x equals b. We want to do a trapezoidal approximation that starts at a and ends at b. To do that, we take the interval from a to b and we subdivide it into 4 equal subintervals. And maybe I should have called this subintervals. We'll work out that terminology. So, what do we have? We're going to have a projection line from the point directly above A, and then directly above this point here, and directly above this point here. Probably not doing a very good job of making these vertical. This point here, no, I did a bad job on that one, and this point here. Okay? And of course we need 4 trapezoids. Right now we just have projection lines, but we have a projection line, put the projection lines for one trapezoid here, another here, another here, and another here. Then I do the slope segment for each. And now we have 4 trapezoids, bounded above by the slope segment, on the sides by the projection lines, and below by the x-axis. Well, if we know the coordinates of these points, as we might, for example, if this is given by some function that we can evaluate at the point A, at the point B, and at the points in between, then we know the dimensions of our trapezoids. So we assume that we know the y coordinates, okay, the lengths of these projection lines, and also that we can calculate these x coordinates. So I'm going to do a little labeling. Okay, first of all, we can label the x coordinates of these points. Now, we don't have specific numbers here, so I can't put down specific numbers, but I can say that I'm going to let x sub 0 equal a. So x sub 0 is the coordinate here at the left, and we're going to have 1, 2, 3, 4 additional x's, so we're going to have an x4 out here that's equal to b, and then dividing this interval into 4 equal parts, we'll also have x1, x2, and x3. All numbers that we can easily calculate if we know the coordinates of a and b and know that there should be 4 equal intervals. Then y0 for the length of this projection line, y1 here, y2, y3, and y4 for the lengths of these 4 projection lines. And these, again, if we have a formula for our function, we can easily then plug in our values of x0, x1, x2, x3, and x4 to get y0, y1, y2, y3, and y4. Now, having these lengths, the lengths of these altitudes of our various trapezoids, and our x coordinates, we can easily calculate, first of all, the width of each interval. And in this case, the width of each interval is going to be just the distance from A to B divided by 4. Distance from A to B is just B minus A. So we have B minus A divided by 4 is going to be the width of each trapezoid. I'm not going to label that as clearly as I might, but I'll put that in here in just a second. So having that knowledge that every width is quantity B minus A divided by 4, we have the width and the 2 altitudes from which we can easily then calculate the slope and the area. Okay, so I've just indicated the widths are B minus A divided by 4, and little arrow to each trapezoid width indicating that that is the width of the trapezoid. Now, having calculated our projection line lengths, which will be our altitudes of our various trapezoids, and knowing the widths, we don't have any more need of x0, x1, x2, x3, or x4. Okay, so we can kind of dispense with that, having used it. And now we just work in terms of knowing the width of each trapezoid and the two altitudes, and it becomes very simple to calculate the slope in the area. I'm going to indicate that. So now we see the slopes, which I'll indicate M1. M is a quantity or a symbol that's often used to represent slope. We could use other symbols. I could write out slope 1, slope 2, etc., but that would take up too much space or the writing would be too small. And with the chalk, I couldn't write it that small. So we've got M1 for the slope here, M2, M3, and M4. For the first, second, third, and fourth trapezoids, then we have slopes. Then we have areas, A1, A2, A3, and A4, calculated in the usual manner. And then I've added another thing. It might be a little hard to read, but it just reads AA1, AA2, AA3, and AA4. And that stands for accumulated area. Accumulated area 1, accumulated area 2, accumulated area 3, accumulated area 4. Now, my convention is the slopes are in rectangular boxes, the areas are in circles, and the accumulated areas are in parentheses. And I usually want to put those directly beneath my areas, since they're closely related. We'll explain that in a minute. Okay, now I've represented my first trapezoid down here, so maybe I'll label this the first trapezoid. And we go from left to right as usual. So the first trapezoid, that doesn't look exactly like this trapezoid. It's a little wider, maybe not even quite as high, but the scale is not particularly relevant to the calculation. And I just want to put this down here in such a way that I can indicate the calculations. So we have the dimensions of the triangle. Width is b minus a over 4. The altitudes are y0 and y1. Again, quantities that we can easily calculate if we happen to know a formula for the function, and the information about the x coordinates and so forth, and the slope m1, and then we're going to have the area a1 and the accumulated area aa1. So here's a1. And here's that mysterious aa1 that we'll try to explain as we go on. So now our task is to calculate first M1 and A1. We're not going to worry about accumulated area just yet, but M1 and A1 in terms of what we know, which is Y0, Y1, and the values of A and B. So how are we going to calculate M1? What's M1 going to equal? And then what's A1 going to equal? Well, I'm going to write these down and briefly discuss them, but see if you can get those before I do. Okay, well, we want to calculate the slope, so we first do the rise, which is just going to be y1 minus y0, y1 minus y0, the rise. And, of course, we can indicate that here as we've done in the past, and here's our rise. And I'm not going to label that or anything, but here's our rise and here's our run. Run is equal to the width, rise is the change in y from here to here. It's y1 minus y0. The run is the width, which is b minus a over 4. So that the slope is rise divided by run. Y1 minus y0 divided by the quantity b minus a divided by 4. And this complex fraction, and we invert the denominator. It's this divided by this. So it's this times 4 over b minus a, which gives us 4 times y1 minus y0 over quantity b minus a. Okay? Now, to get the area, that's straightforward as well. The average altitude is just the sum of the two altitudes divided by 2. That's y1 plus y0 plus y1 divided by 2. And this is a little bunched up here. I apologize for that. But we have a1 equals then the average graph altitude y0 plus y1 over 2 multiplied by b minus a over 4. So right there is our calculation scheme. So we could actually follow these this calculation scheme without even understanding what any of it means. But of course, we've worked to understand what everything means up to this point so that we should be able to see the meaning within these algebraic expressions. Now, I'll also comment then that the average altitude 1 is just equal to the area 1, okay? And we'll see average altitude 2 is not going to be equal to area 2. All these formulas translate over just fine, or all these calculation schemes, because they're not really formulas, they represent something. And then, I guess, it's not a formula to grab and use meaninglessly. It's something to use while understanding what everything really means. Okay, so now we want to calculate for the second trapezoid, and that's going to be very simple. All we do is we change y0 and y1 to y1 and y2. And then, of course, this becomes M2, A2, and accumulated area 2. The width, b minus a over 4, is the same for all trapezoids since we chose to use equal intervals. Okay, I suggest that before you look at anything else on the board, you calculate the expressions for the second trapezoid. Of course, I've done that up here, so hopefully you stopped and calculated that or wrote down the expressions. And the expressions are very straightforward. Instead of y1 and y0, I have y2 and y1. So where I've got y1 minus y0 here for the rise, I'm going to have y2 minus y1 for the rise. I'm going to have the same denominator, b minus a over 4, and it's going to give us the completely analogous expression. All I've done is replace y1 and y0 by y2 and y1. And similarly for the area of the second trapezoid, obviously I'm going to average y1 and y2 to get the area of this trapezoid. And then I'm going to multiply that by the same width, b minus a over 4. Now, just observe in passing, but of course I could multiply that 2 by the 4 and get the 8, but then you wouldn't be able to see what the 2 means and what the 4 means as directly. Once you understand that completely and just want to use a calculation scheme without a lot of meaning, or if you want to program the thing, it would be okay to do that, but I think it's better to keep the original numbers with their original meanings. Okay, you get more insight that way. Okay, then accumulated area 2. Now, I haven't said what accumulated area is. Okay, I'm going to tell you now. It's equal to accumulated area 1 plus area 2. Now, what's this mean? Well, accumulated area 1 is just the area of the first trapezoid. If I add to that the area of the second trapezoid, A2, then I get the total area of these two trapezoids, which is the area that's been accumulated from here to here. Now, let's go on and see if you can write down the expressions for the third and fourth trapezoid. Okay, it should be very straightforward to see that M3 is y2 plus y3 over b minus a multiplied by 4. Now this third trapezoid involves y2 and y3. So any place we had y1 and y2 in the second trapezoid, we'll have y2 and y3 here. And similarly, we'll have y3 and y4 in our calculations for the fourth trapezoid. And the accumulated area of the third is the accumulated area of the second plus the area of the third. That is, the area we obtained through here added to the area we obtained here gives us the area from here to here. And similarly, A4 is going to be AA4 is going to be the accumulated area from here to here, the total of the area of all four trapezoids.